this is the name. That's just the name. The name of this function is g. Right? That's all it is. What, Karima? Oh. Okay, so the name of this function is g. It could be f. It could be any letter, h. Right? It doesn't matter. So we could have another function, k of x. And let's say that one was x squared plus 2x minus 1. Right? So the name of this function is k. They're just different functions. The way the notation works, though, in case you forgot, like you might be asked to evaluate this. And all you got to do is take the 2, plug it in for x. Because you see how the x was replaced with 2? So all you got to do is every single x you see, you just replace it with 2, and then you follow the order of operations. So let's see. That'd be 10 minus 4 is 6, divided by 3 is 2. Is that correct? Yeah? Is that okay? Okay. So Sophia, what this would mean then, like the answer would be g of 2 is 2. That might be confusing. Maybe I should have made up a different number so they weren't the same. But then your coordinate, like this is the x coordinate, and this is the y coordinate. So like another example would be g of 0 would be 5 times 0 divided by 3, right? What would this be? Like if that's 0, what are you finding? Y-intercept, because x is 0. So that would be what, negative 4/3? So your coordinate for that would be 0, negative 4/3. Yeah? Yeah? Okay. Now, you can plug in anything for x. You could even plug in like a whole different function. Like for example, you could have g of k of x. And for Cambridge, sometimes they write it like this. Like in the United States, we sometimes write it with this big O, like that right there. It's not a solid dot, like a little circle. It's called composition of functions. All it means is that you take the function k and you plug it in for g. So like this would be like you're going to take k right here, this whole thing right here, k, and you're going to plug it in right there. And then you would distribute and combine like terms. So it would be like 5 times. Do you see what I mean? Yeah? So you distribute, combine like terms, reduce. Yeah? Isaac, we're good? Alright. So you could add them, subtract them, whatever. Adding these would be kind of tricky because you'd have to multiply this one by 3 to get a common denominator. Do you know what I mean by that, Sophia? Yeah? Mia, you sure? Alright. Sorry, Sophia. Alright. The hard part, though, well, not the hard part, it's actually pretty easy. But the part that April asked about this morning and a bunch of people had questions about was, what does that mean? This is not an exponent. That's not an exponent. It means inverse. It means the inverse function. So do you remember, like you know, g of x is the same thing as y, right? Do you follow me? Like, do you remember, like, this is the same thing as y, g of x is the same thing as y? So what it's asking for is the opposite function, the inverse function that does the opposite arithmetic and with respect to the order of operations. So what you do is you first write it with y equals instead of g of x, and then this is not a math step. It's like these two are not equal, right? So this isn't like algebraically the same. We're actually doing a trick to help us turn it around. So you like swap the x and y, and then you solve for y. So after we replace, interchange them, then we solve for this y right here. So the first thing you do is multiply both sides by 3, right, America? Right? So multiply both sides by 3. Those 3's reduce. So 3x equals 5y minus 4. And then you'd add 4. Good. And then you would divide by 5. So our new equation is y equals 3x plus 4 divided by 5. So g of negative 1, sorry, the inverse of g of x, I don't know why I said it like that, 3x plus 4 divided by 5. Yeah? Questions? No? Isaac, do you remember doing that at all or no? Yeah? Kind of? It was like the variation stuff. It was really easy, and we didn't spend a lot of time on it, and then you forgot. Mario, do you remember that at all? A little bit? Alright. So, here's a fact. I don't think they ask you this so much on Cambridge, but here's the fact. Things are inverse if you take the composition of the functions and it equals 1. So if you take the inverse of g and plug it into g, it equals 1. And then if you do it the other way, and it also equals 1 that way, then you're good. So let's see if that works. Let's plug in. Let's do another one. No, not 1. Not 1. X. My bad. I don't know why I said 1. Do you know why I said 1? Me either. Because it's early. Yesterday was a very long day. I apologize. I confess, though, it's Christina's fault. Sorry, Christina. Well, not really, but I should be. So let's see if that works. So, let's see. G of x was, what was it? Is that what it was? And the inverse was, is that good? Yeah? So let's check both ways. Let's do this way. And then let's do this way. Do you guys understand the difference between these two? So on this one, you're taking this function and plugging it in for x right here. So you're going to take this entire function right here and plug it in for x. So it's going to be like 5 parentheses, right? Minus 4 divided by 3. And you're going to take that and plug it in right there. You see what I mean? Hector, we're good? And it looks all scary and ugly, but it always works out really easy if you did it right, because everything's going to reduce to just be x, like every time. Like Disney. At the end, it just works all magically. The Disney moment's going to happen in just a few minutes. Watch, you'll see. It's going to be beautiful. Yeah. It's going to be lovely. It's going to be sweeter than that cinnamon roll you're not supposed to be eating right now. All right. So, can you reduce these 5s, right? Yeah. Is that good? Right? For sure. Don't distribute, reduce. It's easier. And so then I'm going to go ahead and rewrite it. So it's going to be 3x plus 4 minus 4 divided by 3. Is it starting to you starting to see where it's going to happen? Look at this. 4 minus 4 is famously known as 0. Ta-da! 3 divided by 3 is 1. It just equals x. Oh! Yeah. Beautiful, huh, Ruby? Alright. So for the next one, though, we take this function and plug this in for x right there. So I would do it this way. Right? So I'm taking the inverse function, and so instead of x I wrote parentheses, and what I'm going to substitute is that. Good? Yeah? Reduce again, like these 3's reduce, and then you're left with, whoa, Sebastian, look at that. How you like them apples? The 5's reduce, X. Boom.